right. So here we are doing free code camp, legacy Python for everybody, introduction elements of Python. All right. We got our, what is this thing called? We got our notes ready. We got the logo slapped. Let's get to it.
So now we're going to start learning the actual Python language.
Right.
So what do we say?
All right, let's copy this stuff down. So elements of Python. Let's come down here. Elements of Python. All right. What do we got here? I'm going to shorten this up. Bring this down, and let's do it. So vocabulary words. Vocabulary words. So variables and reserved words. All right. Let's say chapter 2. That's probably where we'll find it. We've also got sentence structure. So valid syntax patterns. All right. Chapters 3 through 5. All right. And then we've got story structure. And then we'll say constructing a program for a purpose. All right. There we go. So let's watch.
You can think of this as almost like writing a story. We're going to start with a basic vocabulary. We're going to talk a little bit about lines or sentences, and then we're going to start talking about how to put those sentences together to make a coherent paragraph, as it were. And you just have to accept the fact that when I start teaching you this stuff, it's not going to make sense for about 6 or 7 more chapters. And so just sort of bear with me, except, I mean, I remember when I first learned, it went from me confused. Holy mackerel, this is awesome.
All right, so he's right about that. He's totally right about that. I remember when I started, because there's a lot of stuff that looks like math in this, but it's actually not math. And I got up to calculus 3 in college. So, I'm looking at like x equals this, and I'm just thinking, what is this? But it doesn't mean x equals anything. It's just they use the equal sign for. We'll see it in a little bit.
And so I expect many of you will go through that same thing. So just learn the first parts, accept the fact that it doesn't necessarily make sense in a big picture.
If you're fresh.
And just bear with us, okay? So we'll start with vocabulary, we'll start to make sentences, and then we'll have little short stories and paragraphs, okay? And so this is a short story about how to count the words in Python. It's got a couple of paragraphs, and we are going to look at all of this stuff eventually. So we start.
All right, let's copy down these reserved words. All right, so these are words that we can't use. And this is the second. I had to re-record this, so that's why I know what's going on. These are words that we can't use because they are as variable names or identifiers because they are already reserved for certain stuff. And we'll get into all that stuff later. So let's come down here and say reserved words, all right? It's just like the let keyword in JavaScript and const and stuff. You can't say const because const is already being used, All right, so you cannot use reserved words as variable names /identifiers. All right, and then let's copy them all down right here. So we've got false class, and I guess we can use lowercase false. I don't know. Anyway, I don't think that would be a good idea, but I think we might be able to. Anyway, let's keep going. Return is finally none with a capital N if for lambda continue true with a capital T def from while non-local and del global not with as elif try or yield assert else import pass break except in raise. All right, and we're only typing these out just to get it into our minds, you know what I'm saying, just so we can have one go through and say later, oh wait, yeah, we can't make import, or we can use import, something like that. Okay, so let's get back to
with a set of reserved words. And what are reserved words? Well, they're words that Python expects when you use these words that they're going to mean exactly what Python expects to mean. And what it really means is you're not allowed to use them for any other purpose than the purpose that Python wants. It's sort of part of the contract. It's like when you have a dog and you go, what did you think of that television program? And the dog has no idea what you're saying. And then you say, do you want to wait until Saturday to go to the veterinarian? And the dog still doesn't know what you say. And then you go like, how would you like to take a walk? And then the dog goes, walk. I know what that means. And then hits the door, right? And so the way the dog sees you is blah, 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 walk, blah, 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 food, blah, 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 treat, blah, 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 walk. That's kind of how Python looks at these reserved words. When you say class, It goes class. Oh, I know what that means. Now, if I say zap, it's like, oh, zap something that you get to decide, or it's maybe a variable name. So reserved words are simply words that when you use these words in Python, and there's only a few of them, like and or del, or if maybe, pass maybe, in. A lot of these, you won't end up using them. It's just these are reserved for Python and part of the Python vocabulary. This is Python vocabulary.
All right, let's copy this down. All right, so let's bring this thing up. Boom. And so this, let's write this. It's going to be sentences or lines. So sentences or lines. All right. So for this, we're going to have x equals 2. So x equals 2. And we'll make a little arrow. And we'll say that this is an assignment statement. Assignment statement. Okay. Then we've also got x equals x plus 2, which this is assignment with expression. All right. And then we've also got print x. All right. And this is going to be print statement. All right. Print statement. There we go. Right, and then we've got all these down here, and it's basically the color coding. I guess it's the color coding for his little what are the slides. And so we're gonna have variables are gonna be orange. So variables are going to be orange. Then we'll have operators are going to be white. All right. We'll have constants. Constants are going to be blue. And then we'll say reserved words. Reserved words are going to be yellow. All right. So that's something we can remember. So if we see like a blue anything, it's going to be a constant. These are all the variables, the little oranges, and then the reserved words, and I guess the function names too. I don't know. We'll see. We'll see about that. But anyway, let's go over this just in case if you're fresh. This is not like math, okay? Because look, if this was math, we would take that, and we were solving for x, we would take the x over here, and then it would be 0. 0 equals 2. That's not a thing, okay? The only reason we're using these equal signs is because it's something that is on the keyboard, and it kind of makes sense. Okay, so X now equals 2, all right? And next, so that's going to make X now equal 2 whenever we call X. And then now X now equals X plus 2. So X is the X before, which was 2. So this is 2 here, plus 2. So this X, we just reassigned this X to be 4 because it was 2 before, and now it's 2 plus 2, which makes it 4. And if we do it again and say X equals X plus 2 again, it's going to be 4 plus 2, which will make it 6. All right, we'll get into that later. Let's watch.
Now, when we move from words to sentences, you see that Python is a series of lines. A Python program is a series of statements. They have an order because the computer wants to know what next, what next, what next. So what next is start at the beginning. So I already talked about an assignment statement that basically says X equals 2. This is not a mathematical statement. This is a directive to say, take this variable 2, this value 2, this constant 2, and stick it in a location in your memory, and remember that I asked you to name it X. X is a variable, something you made up. You chose that. And so, but it's Python's job to remember it. So this says, go to whatever that X is, there's a 2 in there. Now pull that X back out, add 2 to it, which makes it 4, and stick it back in X. And so that makes this a 4. So X is a 4. And print X says, go look up that thing that was an X and print it out. And so these are like, each line has something to it. I'm using a reserved word. Well, actually, that's a function, but it's a reserved word too. And so there's reserved words and all these things, and you combine these. There are operators. Plus is an operator, equals is an operator. These things do things, and we'll learn all this stuff in time. So the basic building blocks of lines of Python. Now, as we take these lines of Python and build them up, we end up making paragraphs, programming in paragraphs.
All right, let's type this down. So let's go down here. Let's say Python scripts, Python scripts. All right. And then we'll say interactive Python is good for experiments and programs of 3 to 4 lines long. All right. Most programs are much longer, so we type them into a file and tell Python to run the commands in the file. All right. In a sense, we are giving Python a script. Okay. And then as a convention, we add .py as the suffix on the end of these files to indicate they contain Python. All right. So yeah, that's basically it. He'll tell us what's going on.
And so one of the things that it's important is I showed you how to do interactive Python. So you just type Python and you type a statement and a statement and a statement. Those get really tiring after about 3 or 4 lines of Python because you start making mistakes and you have to start over. So the better thing to do is to, as your program gets a little larger, to write a script. Put your Python instructions in a file and then tell Python to read from the file and then run the script as it's entered in that file. We tend to name these files with .py, and I've got a series of videos that you can watch to figure out how this all works. Like I said, you can type interactively to...
All right, let's type this. All right, so... Hold on. All right. Interactive versus script. Okay? So, interactive. We type directly into Python 1 line at a time, and it responds. All right? then script. We enter a sequence of statements or lines, yep, into a file using a text editor and tell Python to execute the statements in the file. All right. See what he's talking about.
Python, and it's a great way to experiment with Python, check to see if a statement does what you think it does, but script is the way. After we are past 1 or 2 lines of code, we write it in files and then run it separately.
True. All right, let's do this one. All right, so let's program steps or program flow. All right. So like a recipe or installation instructions, a program is a sequence of steps to be done in order. True. Just like when he was doing the little Macarena earlier. Some steps are conditional. They may be skipped. All right. So those are like the if statements right there. That's what he's talking about there. And if you're fresh, we'll get to that. Sometimes a step or group of steps is to be repeated. So that's kind of like the while loop. Or loops in general. So sometimes we store a set of steps to be used over and over as needed several places throughout the program. All right, and so that one's talking about functions basically. So that's going to be in chapter 4. All right, so let's get to it.
So there are a couple of basic patterns, and it's really important to understand each of these patterns. And like I said, we'll teach you these patterns separately, and then we'll combine them together. And when you combine them together is when you say, oh, that's what a program is. So you have to suspend disbelief. We have a couple of different patterns. One is a sequence of steps. Do this, then do this, then do this. Conditional is like skipping something. Repeated does it over and over and over again. Computers are really good at repeating stuff, much better than people. People get tired going over and over doing the same thing. And then we have store and repeated steps as well. And so if we take a look at this, and we...
All right. Let's just put sequential steps in this stuff here because how are we going to do that? Anyway, let's get the thing out, and we'll come down here, and we'll say sequential steps. When a program is running, it flows from one step to the next. As programmers, we set up paths for the program to follow. All right. So let's just go over this. He'll go over it too, but let's go over this before he goes over it. So we're assigning X, we're assigning 2 to X right here. So X now equals 2. Whenever we call X, like right here, it's going to print out 2. Okay. And then now on this one, we're assigning we're assigning X plus 2 to X. All right. So it's the 2 that from before plus 2, which makes it 4. All right. And then when we print X again, it's going to print 4 because X got changed here. So now this print X does 4. Hopefully that makes sense. So first it's 2, we print it printed 2, then we changed it, and it printed the change. All right, hopefully that makes sense. Let's watch.
Take a look at a Python program. This is a piece of code. This is a little script. If you type this into the code, take this code, Python code, into a file and ran it, it starts at the beginning, and then it goes to the next line, and the next line, and the next line. And Python executes the scripts as you write them. So it says stick a variable to find a place called in your memory called x, stick 2 into that, okay, then go to the next one, print that out. So the program is producing output. Now go read x and add 2 to it and stick it back in x, so x is 4, then print that. This side over here, this is called a flow chart. I'm not going to make you draw flow charts. I'm only going to draw them a few times that in ways that I think will help you. But you can think of it as Python, when it finishes something, it goes on to the next one, unless you tell it otherwise. Finishes this, goes on to the next one. Finishes this, goes on to the next one. Finishes this, and now the program is all done. And so that's sequential steps. You just type them in, Python runs it. They're important, but sort of uninteresting, because you can only get so far. And you can't really make them intelligent because it's always going to do the next one. So the next thing we do is what are called...
All right. Yeah, let's just look at this before we go through it. All right, so we've got, and this is like, before this, that was the end of my first recording. This is all new to me. All right, so now we've got x equals 5. This is the conditional step. So the if statements, like ifs right here. So x equals 5. Is x less than 10? This is basically asking in these diamonds, is asking is questions. Is x less than 10? If yes, print smaller, all right? It is actually. So we would print smaller, right? Is it greater than 20? No, it's not. 5 is not greater than 20. So we're going to print bigger, all right? Well, pardon me. So it's not. So we're not going to print bigger. Okay, cool. All right, let me do that. So x equals 5. Is x less than 10? Yes, it is. Print smaller. Is x greater than 20? No, it's not. Skip this part, okay? And then after all this is done, we're going to print finis like that, right? And that's basically what this is. X equals 5. If it's greater, if it's less than, print this. If it's greater than, print this. Print finis. And it only outputs smaller because that's what it is. It's not bigger. Hopefully that makes sense.
Conditional steps. And this is where it starts to get intelligent. I mean, where you are able to encode your brain into the computer. Like, oh, wait a sec, let's only do this step if something is true. And the syntax that we tend to use here is the reserved word if. Okay? And so the if is like a fork in the road. You can go one way or you can go another way, and you're asking a question. So inside the if statement, right here, there is a question saying, is x less than 10? That resolves to a true or false. If it's less than 10, that's true. If it's greater than 10, it's false.
True.
And so then what we do is, if it's less than 10, we have this indented block of code. There's also this colon that tells us we're in the beginning of an indented block of code.
Yes.
And so what it basically says is, if this is true, run that code. If it's false, skip that code. So it can either run it or skip it, depending on this question that's being asked.
Yes.
Now, if you look at this code, it's pretty obvious what's going on. It comes down, x is 5. If x is less than 10, that's true. So it runs this code and prints out smaller. And then it comes back here, it de-indents the next basic sequential. This ends up being kind of a block. If x is greater than 20, if x is greater than 20, oh, come back. If x is greater than 20, this turns out to be false because x is 5, and so it skips this. So the bigger never comes out, and then it continues on and prints fini. Oops, that's a typographical error. Make that a lowercase print, and then prints fini. So it comes in, runs this, skips this, and then finishes. Okay?
Okay.
So
what did it say though? It doesn't matter. All right, so let's look at this. All right, so this is for repeated steps. So basically the while loop, all right? If you're fresh, this is just how these are like loops, okay? Actually, let's type that down over here. Was there words on that last one? No. Let's at least type something for conditionals, all right? So conditional steps, all right? Ask the code asks a question if something happens, do this. All right, period. But if nothing happens, If the answer is yes, is true, all right, and I'll put yes like this, it does the thing. If the answer is no, and we'll put false, or no. Maybe I should let's switch this up to yes and true. Let's put yes here. And true is what the actual computer knows, right? True. No. And we'll put false here. So if the answer is no or false, or it's false, we're going to skip it. It skips it. It skips it and goes to the next thing. Hopefully that makes sense. All right, so now let's go forward and see.
This is.
All right, let's type in this repeated steps thing. I'm going to try to get in the habit of opening it over here. All right, so we've got repeated steps. All right. Loops or repeated steps have iteration variables that change each time through a loop. Okay, let's define iteration variable while we're here. Iteration variable. Okay. So basically what we're talking about is this little in right here. Okay. Let's go through this first. Okay. So we got in equaling 5, right? Just like before. So we're saying while in is greater than 0. So while in is greater than 0, we're going to print in. And then after we print the in, like let's say it's 5 right here. After we print the in, we're going to subtract 1 from in. Okay, so in now equals in minus 1. So in now equals 4 because it was 5 and now it's minus 1. So it goes back through and does it again. Okay, this print blast off is after this while loop. So it goes back through and does it again. Now in equals 4 because we just subtracted 1 from the 5, right? So in equals 4. So is 4 greater than 0? Yes, it is. Print the 4. Do it again. So in is 4 equals, so 4 in equals 4 minus 1. So now in equals 3, right? So it goes back through and prints 3, goes back through prints 2, goes back through prints 1, right? And so once in is 1, it says in equals in minus 1. So in now equals 0 because 1 minus 1 is 0, right? So is in greater than 0? No, in is 0. So it's not greater. So now it's going to put it blast off after that. So it goes 5, 4, 3, 2, 1, blast off thusly. And this is just one example, right? And so the iteration variable is referring to this in right here that gets changed every single time it loops through, right? Does it 1 time, 2 times, 3 times, 4 times, 5 times. And then on the 5th time, in is 0. So it's not going to do it anymore. It's done. All right. And it does this thing. Hopefully that makes sense. Let's hear Dr. Chuck explain it with a paycheck.
The last one we'll talk about, the repeated steps. We'll get back to store and retrieve later, but for now we're just going to talk about 3 of the 4. This is another program, and the key is that we're going to use this same choice where we're going to go in, but then we're going to run for a while, and then we'll have an exit condition where we get out. So this is a repeated over and over and over and over again, and this is the essence of how we make computers do things that are seemingly difficult, while they're more naturally difficult for people. Okay, and so how do we encode this notion that we want to do something for not forever, but for a while? How do we encode that notion? And so we do it in this way. So we have our statement, sequentially go to this while. While is a keyword, and it's asking another question that's a true-false question. Is n greater than 0? I read this as long as n remains greater than 0, keep doing this indented block. And you have a colon at the end, and then you have 2 lines of code that's indented. So that tells us what the loop is, and then this is now de-indented. And so it comes in, and if this is true, if this is true, if this is true, it runs these 2 lines. Prints out n is 5, and then it says n equals n minus 1, which makes n be 4, and it goes back up, and it goes up and it asks this question again. Is n greater than 0? If it is, continue on, and prints 4, and then subtracts it, and it does that, 4, 3, 2, and prints out 1, then it comes up, and now after this, n is now 0, n is now 0, and n is no longer greater than 0, so it takes sort of the exit ramp and goes down here. So it takes the exit ramp and goes to here and runs the next line. Now, we're going to cover all this again. So I'm just trying to give you the big picture. Next couple of chapters, we're going to hit all these things again, and we're going to hit them in much more detail with a lot better information. This is now sort of like combining these. And again, I don't want you to really like know this stuff.
So it turns out that color coding that we did was just for that one page. Because look, obviously it ain't like that everywhere. So let's just come over back here and find that color coding stuff. Where is it? Right here. Let's get rid of it. Because it's going to be different. He's probably going to update the color coding every single time, right?
You will know this in a couple of weeks. You will see this program again. But this shows you how we combine those patterns of repeated, sequential, and conditional together. And so this is a bit of sequential code. Comes in here, runs this, which happens to ask for a file name. Then it opens the file. It creates a data structure called a dictionary. This is all sequential. Now the for is another form of loops. So this is going to loop for a while. And then this is within a loop. We can even have 2 indents. And that's another loop. So these are like repeated. And then it goes down to the next sequential bit. Then it does this. Here's another loop that's going to run. And then here's a conditional it's going to run. And then when it's all done, we print out the last thing. And this is, of course, is the program that does, it figures out the most common word and prints that most common word out. And so this is a Python short story. It reads some data. It reads the name of a file, it opens that file, it talks about how to make a histogram, and then it looks through for the most common word. So don't worry too much about this. Over the next couple weeks, we'll fill in the pieces so that you absolutely understand every single line of this code.
Right, because I don't want to go over that right now.
This is a quick overview.
Let's type in the summary real quick. Let's finish this up. All right, summary. That's not it. Summary. All right, so this is going to be a quick overview. I don't think we need to write the summary at all, actually. This is all stuff that he's just going to talk about. All right, but yes, focus on the big picture. I guess that is the summary. Summary. Focus on the big picture. All right, that's a good idea. All right, so let's go back through.
Review chapter 1. Stick with us. You realize it will be chapter 7 before this makes too much sense. You really have to trust that you are learning important things and that it all makes sense when we bring it together, like in chapter 7 in a few weeks.
All right, so there's that. Another one down. Okay. So let's go through this. What will the following program print out? What? The following program. Oh, this is a program. Okay, so x now equals 43, right? So now we're reassigning x to be x plus 1, right? So 43 plus 1. And so when we print x, what's it going to be? 44, correct? Of course. All right, we'll click it, check the answer, looks good, and submit it. All right. So now we're on to, did he start doing this at his house? Well, whatever. So now we're on to variables, expressions, and statements. And we'll see you next time.